Well, we have another question here, question 9. The question says that the graph of g of x equal to x cubed plus bx squared plus cx plus d is sketched below. The graph of g intersects the y-axis at -5, 0 and at p equal to p and the y-axis at 0, 20. So p and r are the turning points of g. Now, question 9.1 says show that b equal to 1, c equal to -16, and d equal to 20. So on the right here, question 9.1, we need to prove that b equal to 1, c equal to -16, and then d equal to 20. So when we look at this cubic function here, you know that cubic function has a maximum of three intercepts, but over here we only have like 2 intercepts. I was saying it has a maximum of 3 intercepts. It can be 1 intercept, it can be 2 intercepts, or all the 3 intercepts. Now, in this situation, because you're like only 2 intercepts, okay, it means like the sum function can be written in terms of intercept form like this. G of x would be like, I can say like x, it will be like a, open brackets, x minus x1, okay, open brackets, x minus x2. This is when we have like 2 intercepts, x2 to the power of 2. To the power of 2. Because over here, it's formed like a parabola, okay? So it means like the 2 intercept has the same value over here, okay? Here the 2 intercept has the same value. So it's gonna be of this form. Now, the fact that the leading coefficients here, I'm talking about the coefficient of x cubed is just 1, a is just also 1, okay? This a is also 1. So it is just open brackets, x minus x1, close brackets, x minus x2 to the power of 2. Now, one of the intercepts is already given, -5 over here. So we can write there x minus 5. Actually, be careful here. We're not going to write x minus 5, but we will going to write x plus 5. Just because the x minus 5 here comes from x plus 5 equal to 0, okay? If you move the -5 over, you got x is equal to -5, okay? So, meaning in the brackets here, we're going to write x plus 5. And then, or in other words, if you substitute this -5 over here, you have minus and minus will make +5. Then over here, we'll have like x minus x2 to the power of 2. That's g of x. All right, now we can also substitute this point here, 20, the point 20, in the equation of g of x, okay? Because the point 20, 0, this is the point 0, 20. I mean, point 0, 20. It is a point on the line, on the curve g of x. So if I sub in there, I want to sub 20 for y and then 0 for x, okay? And it's going to be 20 equal to 0 plus 5, close brackets, open brackets, 0 minus x2 to the power of 2, okay? And then that makes like 20 equal to 5 x2 to the power of 2, because 0 minus x2 is just -x2 to the power of 2, x2 to the power of 2 becomes positive, okay? And then 5 here, 5 times that makes that. Now, if I need to find out what the value is, I can just divide both sides by 5, okay? Divide by 5 both sides. And then this will make like 4 equal to x2 to the power of 2. Now, we have x2 to the power of 2 equal to 4. Now, to work out this, we can just square root both sides. Square root here and then square root there. And then this will make like x2. Why square root? Because the square root will cancel this power of 2, and then that makes x2 will be equal to plus minus 2. Then we're going to look at we have positive 2 and negative 2. Now, when you look here, P is on the positive x-axis, okay? The positive x, okay? So therefore, x2 will be equal to 2. Okay, actually it's not really what we're looking for, but let me just write it here. Therefore, x2 equal to 2. Now we can substitute the value of x2 here, there, and x1. So it will be like g of x will be equal to x plus 5 and then x minus 2 to the power of 2. Then we can expand this then. This will be g of x will be equal to x plus 5 times x minus 2 to the power of 2. Be careful, this is not, okay, is not it is not the same as x squared minus 4 squared. Not the same. So this over here we must do x minus 2 times x minus 2, and then g of x will be x plus 5 times here we do x times 2, x times x times negative 2, and this and that, and that makes what? X squared minus 2x plus 4, and that will make x plus 5 x squared minus 4x plus 4, okay, and that makes with times again this, that, this, that, and that would be x cubed minus 4x squared, okay, plus 4x, and then plus 5x squared, and then minus 20x, and then plus 20, okay, and then this will make x cubed, and then like terms like this and that, okay, will make a positive x squared, and then 4x over here, and negative 20x will make a negative 16. That makes negative 16x, and then plus 20. Now we express gx, okay, all the coefficients of the terms of gx, and then we can see that the coefficient of b is 1, and this is the coefficient of c, and that the coefficient of d. Therefore b is 1, c is negative 16, and then d is 20. Yeah, thank you. Well, the other question is question 9.1.2. Let's see. This question 9.1.2. Well, the question says that calculate the coordinates of P and R. So P and R are, we can see that P is the minimum, and then R is the maximum of the function. So the minimum and maximum occurs when the derivative is equal to 0. Okay, so now the derivative of the function. So I'm gonna write here. So we're looking for so 9.1.2. Looking for P and looking also for R. So now we said this is when the first derivative of the function is equal to 0. And then the function itself, as we did find it, is f of x is now equal to x cubed plus x squared minus 16x plus 20. Okay, we want to find the derivative, knowing that when we're going to differentiate this function, we're going to differentiate each term of the function. So following this formula, ax to the power of n, okay, the derivative is just equal to n times a times x to the n minus 1. So f prime of x will be, for the first one, it's going to be like 3 x to the power of 3 minus 2 plus 2x to the power of 2 minus 1 minus 16, okay, 1 times 16 x to the power of 1 minus 1, and then plus the derivative of any constant is just 0, okay? A constant, the derivative of a constant is just equal to 0. So like over here, the coordinate of x cubed was 1. So we first do, a is 1 here, and then n is 3. Okay, so it's going to be 3 times 1, just write 3, x to the power of 3 minus 2, so n minus 1. Same also here, it's going to be like, the coefficient here is 1, so I don't need to write it, so just 2, x 2 to the minus 1. And then here, the coefficients, the exponent is 1 over here, and then, so 1 times 16, x to the x minus 1, and then 20 is just a constant term. It's just a constant, the derivative of a constant is 0. So that make f of x equal to what? 3x to the power of 2 plus 2x, and then 1 minus 1 makes 0, and then x to the power of 0 is 1. So 1 times 16 times 1 just 16, so minus 16 here. That's f prime of x. Now we're going to set, okay, this derivative equal to 0. So it's going to do 3x squared plus 2x plus 16 equal to 0. In this situation, what we do, when you look at the first term, because there we have like, the leading coefficient is different than 1. So we're going to do 3 times 16. This is equal to 48, okay? Now let's list here the factors of 48, preferably in ascending order. So like 1 and 48, okay, 2 and 24, okay, 3 and 16, okay, 4 and 12, okay, and then 6 and 8, and then the rest is repetition. So now in the list of the factors of 48, there must be exactly one couple, okay, that would make a sum equal to positive 2 here. Now let's see which couple is that. This will never make positive 2 regardless of the combination, okay? But 6 and 8, yes, it will if we do, if we have like a negative 6 and a positive 8. So the same equation here, we can be rewritten as like 3x squared. Okay, instead of me writing 2x, I'm gonna write negative 6x, okay, plus 8x, knowing that this is just 2x, and then plus 16 equal to 0. And then I want to take, for the first two terms, I want to take 3 as a common factor, 3x, the common factor. And for the last two, I want to take 8, the common factor. Okay, so this, if I take 3x as a common factor, I'm left with x minus 2. And if I take 8 as a common factor, there's going to be also x plus 2. Okay, it was a negative 16 there. I wrote positive 16 here. So negative 16. So that's going to be minus 16 here, minus 16 here. So that's going to be also minus 2 over here. Minus 2. Now, this is what we notice then. We have like x minus 2 and x minus 2 common. It has to be common, otherwise something was wrong in the calculation, or we selected the wrong couple over here. Okay, and then we can continue factorizing. We're gonna do 3x plus 8 and then x minus 2 equal to 0. So this means that over here 3x plus 8 equal to 0, or x minus 2 equal to 0. To work out the value of x, this makes 3x equal to negative 8, or x equal to 2. And then here, this means x is equal to negative 8 over 3, and then x is equal to 2. So those are the solution. One is the maximum, the other is the minimum. Now, which one is what? Okay, now let's look at the graph. We have negative 8 over 3 and 2. If I look at the graph here, so this R here is on the negative side of the x-axis. So this is where x is equal to negative 8 over 3. So negative 8 over 3, and this one is exactly at 2 there. And it's the same value of 2 that we find here when we were calculating the x-intercept, because P is also the x-intercept. Now the maximum and minimum are just so this is the maximum. R is the maximum, and then this is the minimum. Now the following question is question 9.1.3. The question says that is the graph concave up, down, or down at the point 0, 20? Show all your calculations. Okay, at the point 0, 20, at this point here, is this graph concave up or down? Now, let's show calculations. Okay. Over here, okay, to determine whether the graph concave up or down, if the second derivative, okay, at that specific point is if it is positive, then it's concave up. If it is negative, then it's concave down. Now I'm gonna do over here. We had like G prime. We already found G prime in the previous question, and then we got G prime was equal to 3x squared. What is it? Three x squared plus 2x minus 16. Okay. Now that was the first derivative. Then the second derivative will be equal to, applying the same formula, it's going to be 2 times 3 times x to the power of 2 minus 1 plus 1 times 2 times x to the power of 1 minus 1 minus 16. So I follow this formula here as I did in the previous question. So we differentiate for the second time, and this will make 6x plus 2, because this just make all this part makes 1, and then that's going to be 0. Then if we set this equal to 0, sorry about this, equal to 0, I'm gonna move 2 over, so that's gonna be negative 2 equal to 6x. Oh, I don't need to do that. So I have g second of x equal to that. Now at the point that's at x is equal to 0, for instance, meaning I would substitute x by 0, and then g prime of 0 equal to 2. So 2 is positive. So at this point, the graph concave up. Say concave up. Okay, accept 0 because we're talking about the point 0, 20. So the x coordinate of the point is 0. So accept 0 there for x, and then we got this. Thank you. Well, we have another question here, question 9.2. The question says, if g is a cubic function with g of 3 equal to g prime of 3 equal to 0, and g of 0 equal to 27, and the second derivative of g is greater than 0 when x is lesser than 3, and the second derivative of g of x is lesser than 0 when x is greater than 3. Draw a sketch graph of g indicating all relevant points. Now, okay, it is important to know the meaning of the function at certain points, and also the derivative of the function and the second derivative of the function. So now, let's see. For the first one here, g of 3 equal to 0 means that the x-intercept of the function g is at x equal to 3, because when x is equal to 3, g of x is equal to 0. So x here is 3 here is the x-intercept. So I'm going to say here x int is just 3. Okay. And then g prime of 3, okay, equal to 0 means that it has the maximum, the function g has a maximum at the point x is equal to 3, because the derivative of the function equal to 0 means at this value here 3, the function has it's either maximum or minimum. Okay, so the turning point, I meant to say, the turning point is when x is equal to 3. So I'm right here, xtp equal to 3. So remember, the turning point can be the maximum or the minimum. And then g of 0 equal to 27, this simply means that 27 here is the y-intercept. So over here we have like y-intercept, y-int equal to 27. Okay, and then when the question says that the second derivative here is greater than 0 when x is lesser than 3. So this means the function g concave up, okay, when x is lesser than 3, in that interval from -infinite to 3, okay, then the function is concave up. And then g second lesser than 0 when x is equal to, is greater than, okay, lesser than 0 when x is greater than 3. This simply means, okay, the function here concave down when x equal to is greater than 3. Now here I'll say this part here concave up, and then there I'm just gonna abbreviate it like that because of space. I'm gonna say concave down there like that. Now let's draw the function. Now I can draw it. I can draw it over here. I'm gonna draw the vertical axis. Okay. Let's see, it's the vertical axis, and then I'm gonna draw also the horizontal axis. Okay. The horizontal axis is this one. Okay. And then we have like, let's say the point 3 is somewhere there. All right. Now, let's say the points, put it over here. Right. Now, and then that's the point three, the x-intercept, and then the y-intercept is 27. So this one g of 0, the y-intercept 27, 27, and then what else? Okay, now I know that it has a turning point here. So if this is the y-intercept, I understand that the graph is decreasing like this. Okay, and then over here it has a turning point. So the graph must be something like something like I'm gonna draw something like this. Okay, because it has only one intercept. I mean, yeah, one x-intercept. So the graph goes down like, oops, the graph goes like, trying to connect 27 with this graph. Yes, that's the cubic function. Yeah, that's g of x. Thank you.